Publishing internal resources part 2, or should I say the surprise part 2. I'm going to pick up right where we left off in the first publishing internal resources nugget, because this is kind of the continuation of that. Now looking back at this, I have no idea what I was thinking when I thought I could cram all of this into a single nugget, because there is a lot to configuring web publishing, and especially the secure web server publishing that we're going to talk about. So if you haven't seen part 1, please check that one out, because that will fill in the foundation of where I'm going to begin. What we're going to see in this is the rest, you can see my half bullet here, the rest of configuring web publishing and tweaking it to be a secure web publishing, even for a standard HTTP web server. We'll then get into secure web publishing and something known as SSL to SSL bridging, a daunting task that is very powerful, but a lot of administrators shy away from. We'll then finally wrap things up by taking a look at the other server publishing any other server using ISO Server 2004's publishing capabilities. This is right where we left off in the initial publishing nugget, and if it's been a little while since you saw that one, let me just refresh you. When we configured the initial web publishing rule, we walked through the wizard, which is located on the Tasks tab, published a web server, brought that up, walked through the publishing rule allowing access to an internal web server, and we also ended up creating a web listener on the external interface to the internal interface that allowed the people to connect to the external IP address and use HTTP to reach the inside network. And that's where we left off, was looking at the properties for that listener and just getting into the properties that we're able to tweak for this internal web server. Now when I right click on this, you see that we're able to export and import, configure HTTP, and this is where we can get into the specifics for the security that we're allowing for our publishing rule. But most of what we're going to do, and I'll get back to that, because most of that is handled under the Properties tab right here. This is where you're able to tweak your publishing rules to allow specific access to your published web servers on the inside of your network. Now you can see right here the public name has what name this will reply to, and this was part of, when we walked through the wizard, part of what we adjusted. Now we can adjust this web publishing rule to add specific website names. For instance, this one will only respond to www.cbtnuggets.com, and at that point, when an incoming request for port 80 comes in, the ISO server looks up multiple layers to the application layer data to see what website that person is requesting. Let me jump to a web slide real quick on this, because I want to make sure you grab it. Did I call this a web slide? I meant a whiteboard. This is going back to the OSI model, and forgive me for sloppy penmanship, this is kind of on the fly. There's my OSI model with all my 7 layers coming in here. 1, 2, 3, 4, 5, 6, 7. Okay, now down here we've got our physical data link and all that. We're actually working right here. That's what I want to focus on when we're talking about communication, and up here. When we're communicating, let's say we have a host communicating to a web server. At the network layer of the OSI model, this host is saying, I want to go to that destination IP address, and I'm coming from this source. Scribbles. My source IP address that's sitting down here, so when the web server responds, it knows where to send that information to. Now, that is not what I'm talking about when we were looking at the domain name. I'm talking about this right here. At the application layer, we have that protocol HTTP, which this web client is sending here. It's saying, I'm sending a destination IP address, sure, but an HTTP request. And if we open that up and look inside of that request, it's saying, hey, the type of request is a GET. I'm trying to get information, and I'm trying to get it. It will say from the host www.cbtnuggets.com, or whatever website that client plugged in will be listed right there in that request. So when it's received at the web server, sure, it sees the destination IP address, but it also sees the host domain name that you're looking for. So when we're filling this in and we're saying www.cbtnuggets.com, it doesn't really relate to an IP address. We're not talking about filtering based on IP address. I'm talking about looking up at the application layer data. that the client sent to find out what website they're actually looking for. So this allows us to have a single IP address on our ISO server that actually responds to many different domain names and sends it to different internal servers. That's the power of having that host name inside of that request, is that one IP address can actually match to many different websites. So I had this set to go to all requests, but I could filter it down and say what websites this publishing rule applies to. Now when I go to paths, during the creation, during the wizard process, it only allows me to specify one path. But I can actually add in here all kinds of different paths that I'm using on my website. Maybe I only want to allow access to / ISA server as the name, and I could go ahead and remove that one. But I could put as many directories as I want as specific paths. Now it also says right here external path and internal path. I could specify different external names that map to different internal names, and this is getting just wacky. But I could add in here, if they put, /* on the, or actually let me say on the internal side, / nugget, I could put external path is maybe they requested blah, blah, blah. My creativity is at a minimum right now. And I could map my external path of blah, blah, blah to the internal path of Nugget and allow that sort of request. Now, in my opinion, you're getting a little too crazy there. You're actually redirecting folders to different folders on the inside. But, it's kind of like the feature's there if you want to use it. Now we get to the bridging. The bridging allows you to, for instance, when you receive on your listener on port 80, I could redirect it maybe to the internal port on my web server of 8080 or 8888 or whatever internal port my internal web server is running on. Does port redirection. You could also say when I receive it on the web listener, I want to redirect it to an SSL port on 443. So that means I could receive it clear text on the internet and then use SSL to bridge it to my internal web server using HTTPS. It's pretty rare that you'd receive it clear text and then bridge it. I could see the other way around, but not in this case. Now when you say FTP server, be careful because I know it gets confusing sometimes. Your web listener is what it's receiving on, right? That's configured for port 80. I could then bridge port 80 to an FTP server on the other side. This is useful for maybe I'm going to an HTTP server, browsing the website, and then I want to download a file that's on a web server. Now, behind the scenes, unbeknownst to our external user, I could bridge that web request down to an FTP server that has all the files. This even becomes more useful when maybe I have HTTPS on the external site to where people are authenticating using usernames and passwords or certificates and it's all encrypted, and then I bridge it to an internal web server, or I meant FTP server. I could go ahead and say, go to this FTP server, so that way the credentials are all encrypted using HTTPS, and then I'm sending it to an FTP server, which, FTP requires no username, no password encryption at all. Everything's sent in clear text. But again, when I'm talking about bridging, I'm talking about it coming in on our listener, which is configured for port 80, and being sent to some other port or even another server if we're using FTP. Users, that allows us to select what users, and this is one that we configured during the wizard. Schedule means when this publishing rule is available. Maybe I don't want it to be available all times of the day and night. I can set that up here. Link translation allows us to magically replace web links in the web pages. And this is so cool. Guys, this is what makes publishing with ISA servers so different than just using a firewall. Here's the idea. Matter of fact, let me go to a whiteboard. Let's say that we have a small scenario here. I've got my web server going to my ISA server, going to the external clients out here, right? And let's say this is an intranet as well as an internet web server that's going here. And one of the pages that I have on there, forgive me, I'm not much of a web coder, but let's say that one of the pages that I have on that web server is designed for intranet and intranet use. And we'll just say that that page, for the sake of this example, is called index.htm. And HM quickly becomes HTM. Now, let's say inside of that web page, come down here, open up the web page. Look at that, the folded corner on the web page. I have a bunch of text, and I've got the web stuff. I'm not much of a web coder, so inside of here you've got this shows you how little of a web coder I am. HTML bracket, blah blah blah. And then down here you have one of the href. Is that what it is? Yeah. You have the href, which is a reference to another web page. For instance, maybe the index.html has a link in there that points to another web page that's on another web server on your internal network. Maybe you have true intranet web servers. This is number 2. It's like Austin Powers. Number 2. So this one has a link on its web page that points to that web server. And in the reference, they said this goes to HTTP. If they click this link, http://num2 / and then a web page on there. Now, that web link, that URL right there, works on your internal network because everybody can resolve num2 to whatever IP address number 2 web server has right here. But if you pass that web page out to the internet and they click that link, whatever the ahref maps up to, they click it and it says go to num2. Well, this guy out here has no idea where num2 is because they're not using your internal web DNS server. Or that didn't make sense. They're not using your internal DNS server on your internal network to resolve num2 to the internal name. So, back to the config, we can configure our ISO server to replace the absolute links, that's the internal links in the web pages. And we can create this little mini dictionary where I click on add and say, if you find num2 on that web page, which is the reference to number 2, go ahead and replace it with www.cbtnuggets.com, which means that as it replies and they click that link, or actually, let's say, edit, cbtnuggets.com / num2 or something, that'll redirect it to that internal server of number 2. And I can create this whole list, blah blah blah. If you match that in the web page, replace it with blah 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 blah. And you can just go ahead and create this whole mini dictionary. And tell me this isn't awesome. Stand up right now. Tell me that's not awesome. You can't do it, can you? You don't see, you're stumbling for words because that is awesome. That is the ISO server that's actually watching those web pages go through, looking at them, and saying, "Oh, I'm so psyched out here. I can't even find the words." It's looking at the application layer data. It's not looking at port numbers. It's not looking at session stuff or IP addresses like a normal firewall does. It's looking at the web page, finding words that are in that web page and replacing it with other words as it's responding to the external IP addresses. You know what? I'm going to pause this recording. I'm going to breathe. Oh, okay. Much calmer. Nearly had an aneurysm there. It's all right. Everything's okay. So this will go through that web page, replacing those. And, okay, I'm done. I'm not going to start again. This right here says what content types do you want to be subject to this. So look at this. I click on this, and it says by default it will look at HTML documents, but you can actually, oh, it's happening again. Look at this. You can say, I want when text flies through. If say somebody is downloading a text file via the website, I can go through that text file. I can replace whatever I want in that text file with something else. I can go through the application file. See? It's happening again. Calm. Breathe. Going through the Chinese Kai Chi, drink some tea, relax. This is amazing. And this is coming from a guy who sold on Cisco Pix firewalls. I love Cisco Pix, and there's nothing like this on the Cisco Pix. The Pix can't touch this because the Pix is a hardware firewall. This is getting into the side of things where we're starting to look at application layer data. And this is what differentiates the ISO server. I'm getting off that tab. It's too much for me to handle. Come up here, the general. This is the general. I already saw this, right? Right. Oh, I think I started somewhere else. From, to, traffic. Okay. This is the general area for the web publishing rule, whether you want to enable it at all. Did I start here? See, I got so excited, I think I just lost everything. I talked about that, schedule, link translation, general, action, allow or deny, from, to, HTTP, filtering. Oh, yes, okay, yes, sorry, this is where I left off. We went through these top tabs first. Action, allow or deny, log request matching the rule if you want to commit this to a log file so you can always see what's going on. From anywhere to your web server, and this is where we start getting back into the stuff that we didn't have during the wizard. It says, okay, do you want to send this to this, this is your internal web server. I talked about this during the wizard. Forward original host header instead of the actual one of the most confusing checkboxes ever. That was in the part 1 nugget. Now this is a new part. Proxy request to the published server. It says this specifies how the firewall proxies request to the published server. The requests appear to come from the ISO server computer or to the original client. This tells you how much routing you need to have on your internal web server. By default, the ISO server masks the request, meaning when the client sends it into the ISO server changes the request so it appears like the ISO server is asking the web server for this web page. The web server says, oh yeah, here you go. That's usually good because the web server is the non-intelligent device, meaning it shouldn't have too much stuff in there. It shouldn't have all kinds of routing tables and know how to reach everybody. It should just have a default gateway. So it's fine that the request appears to come from the ISO server. If you check this, it preserves the IP address of the original client that is asking for the web content. So again, this depends on your routing infrastructure. How much does the web server know? That is what checkbox you will check. The traffic. It says right here, this applies to the following protocol. You can't change this because we didn't change anything in the web listener, and this is defined as an HTTP only rule. But this is where we can configure that HTTP application layer filtering. Again, something that non-software based firewalls can't do. Now that was a double negative if I ever heard one. How about this is something that hardware firewalls cannot do. It takes something that can do a deep packet inspection of the application layer data to really get to this level of filtering. Now what you're seeing right here is just looking at the header sizes, and this was actually something we saw this screen before in one of the previous nuggets on the firewall features of how we can allow web access and things like that for internal clients. And we went through all of these back in, it was either Firewall Part 1 or Firewall Part 2, where we looked at each one of these and we talked about how we can limit the header size for the URL length, and then we started getting into this, where we can say what kind of HTTP methods are allowed. And that allows us to filter out other applications that use port 80. You guys remember this from the firewall? When we talked about peer-to-peer and things like that, and how we could actually look inside of the header, search inside, and find certain strings that we would block, like the Kazaa or the Grokster, that we could filter those kind of packets out to block the port 80 borrowing applications. Well, now we're looking at the same features, but we're seeing them from the other direction. We're looking at them for allowing access to our internal web server. So we're saying what methods can be allowed. It might be good, for example, if you know that your web server is just using basic web services, just to allow certain methods, and you can go in here and type in, the GET or the POST or the whatever HTTP methods there are, and again, Google out for HTTP methods to see what they all are, to allow the basic functionalities. But if somebody tries to do something with your web server that doesn't fall under one of those methods, you'll block them. Same thing with the extensions. What extensions for file extensions do you want? For the headers, and this is all the same stuff that we looked at back in the firewall nugget with HTTP filtering, but now we're doing it for our internal web server. Finally, you have the listener, right there, which says what listener it's using. These are network objects. We can define many different listeners that allow different port numbers. For now, we're just focusing on the web services, so of course we have port 80 that's defined. That's everything. Oh, what did I do here? The mapping, same as internal. Yes, because I'm overlapping. The /* encompasses /ISO server, so it's not letting me put both of those in there. I need to take out the ISO server, so I click on OK. That is publishing a standard web server with ISO server style applied, meaning that deep packet inspection, making it ultra secure. Now we can move into the HTTPS, or secure HTTP publishing, now that we've seen the foundations of making a web server available. And don't worry, we won't spend as much time on that one just because it's mostly the same with one huge difference. And that's where the SSL tunneling versus bridging comes in. Now we went ahead and did the publishing web server right here. Now let's hit the publish a secure web server and you'll see the difference. So let's say I want to do a publishing rule for SSL and we'll call it HTTPS server. Now already it comes up and says a new question for us. It has a new question for us. Do you want to use SSL bridging or SSL tunneling? Now with the bridging, this is the one where the ISO server, this firewall in the middle, will receive the request from the World Wide Web, decrypt it, look at it, make sure it's not a malicious attack, and then re-encrypt it and send it to the internal web server. SSL tunneling allows that to go straight through the ISO server. No decryption takes place. It goes straight to the web server. This is the closest thing that there is to port forwarding. It's just sending it right on through. But inside of that packet could be malformed data that's attempting to crash our web server, and our ISO server wouldn't be able to discover it. One of the key features that ISO server provides is SSL bridging, as in all firewalls can do this. And ISO server, to date, is the only one that offers this capability. All others just forward the packet through. So if we choose SSL bridging, which is the better one, to inspect the packet on the way, it has, this is back to our publishing rule. Are you allowing or denying? We're going to go ahead and allow. This is where it's asking us what kind of bridging we would like to take place. And take a look at this. By default, it says secure connection to clients and web server. And first off, make sure you realize who the clients are. Clients aren't inside of your network. The clients are World Wide Web people. Remember, we're publishing here, so outside people are now our clients. So this will be considered secure and then decrypted and then secured to the web server. Now, we also have this one right here, which does the secure connection to the clients and then decrypts it across our internal network. The advantage of doing this one, securing the connection to the clients but not internally, is, well, first off, we trust our internal network, so, hey, why do we need to encrypt? I guess that's kind of a weak excuse, right? The other side is that it's easier on our web server. The web server will be able to handle more decrypted sessions than it would encrypted sessions. So this eases the load. However, it does what I call breaking the bond of trust, meaning that when a client, if you're doing online banking, right? Let's say you go to a Wells Fargo website, you assume that is kept secure to the web server, as in there's nowhere in the loop that that's sent unencrypted. That's something that we would expect. Now, if Wells Fargo came to us and sent an email and just said, hey, just so you know, to ease some load, we are sending your bank account balance and sensitive information across our network unencrypted, just to ease the load on our servers. But don't worry, across the internet, it's still encrypted. Would you still feel good about that? I wouldn't. I'd be like, dudes, no way. You're not going to do that to me. I want encryption the whole way, because what if somebody on the Wells Fargo network, as much as I trust those people, what if they pulled open a packet sniffer and started sniffing my data? At that point, it's compromised. I expect a secure tunnel to the server. So that's usually kind of a travesty to the clients, not you. This one right here, secure connection to the web server, means it will be unencrypted across here. Maybe they just access you on HTTP, and then it encrypts it when it sends across your network. What we will use most of the time is this one right here, security the whole way through. Now, this is where it gets a little complex, because We're going to get into some of the same stuff we've seen, but one of the things that makes people shy away from this is the complexities of certificates and SSL. Let me bring up a whiteboard and show you this. The way cryptography works on the internet and when you're connecting to secure web servers is really neat. It's just getting the concepts down that can be difficult. And the reason why is I think there's a lot of poor documentation out there that either get far too technical than it needs to be or not too technical enough. It remains rather vague. So let me give you the brief overview of how cryptography works on the internet, and then we'll tie it into ISO server. The internet uses something known as the public key infrastructure. And this is a way to create secure communications between a client and a server on the fly across the internet, which sounds a lot easier than it really is, because they had to figure out a secure, unhackable way that everybody could use. Now that's pretty phenomenal when you think about it. Let's do this in terms of practical examples. Let's say that you're connecting to an online banking site, and we'll say this one is the Bank of America. You have your Internet Explorer or Firefox, whatever web browser you use, and you open up a HTTPS connection up to the Bank of America. Now that immediately uses the secure socket layer. That's TCP port 443. And when you first connect up to the Bank of America, they will see that you're attempting to do a secure connection to them and will deliver to your client, your Internet Explorer, a certificate. Now, I'm not going to get too deep into this because I'm just giving you the overview. This certificate will have all kinds of stuff on here, like the name of that this is the official website of Bank of America. There will be an approval entity, and that is known as the certificate authority that approved that the Bank of America is who they say they are. So this certificate isn't only to protect your communication, it's to protect you from counterfeit web servers. Because if it is a counterfeit, then there's no way they could get the certificate from a valid certificate authority that says they are the Bank of America. Now, at the bottom of this certificate is some of the most important stuff. You're going to have this key. And this key is the key to your entire cryptography. This is known as the public key. And all that is an encryption algorithm. Now, how advanced that encryption algorithm or that mathematical algorithm that this is depends on what kind of encryption the web server is using. There's 40-bit encryption out there. The most common one is 128-bit encryptions. But there is levels even greater than that, many of which are banned by other countries, and some of which are even banned by the United States because it gets so advanced that even the FBI and things of that nature, the ultra high level security organizations, are unable to crack it. Now, it's debatable whether 128-bit encryption can be easily cracked by these huge government agencies or not. My guess is, well, I'll leave my guess out of it or else they may be shot. So what happens is this Bank of America delivers a public key to you. And this is an encryption algorithm that cannot be reversed. And what your client does is give a public key to the Bank of America. It's a public key that your Internet Explorer or Firefox or whatever web browser you're using generates and gives to this server. Now you both have each other's encryption algorithm. Now, what you can do is you can encrypt communication back and forth to each other. But how do you decrypt it? Well, on your hard drive and on the bank server's hard drive is something known as the private key. And the private key is the reverse of the public key. It is the decryption, I'll just put private there, and they have the same thing that decrypts everything that their public key encrypts. Now, I know when I first got into cryptography, I had so many questions, especially when it came to this. I thought, well, if you have the encryption algorithm, I mean, the public key is just sent, anybody can get it. Anybody that connects to this web server gets the same public key. So it's kind of thinking, well, if you have the public key, can't you just reverse it? Kind of like, if you had, x plus 1 equals 2, couldn't you just reverse that to say, 2 minus x equals 1, and that's the reverse of that formula? The answer is no, theoretically. This formula is so complex, it is irreversible. It uses logarithmic functions and things like that, things that just cannot be reversed. And I took the word of the person who told me, and you're just going to have to take my word on that, because I don't have the intelligence to really get into the mathematics behind this and easily explain how that formula works. So it is an irreversible formula that only the private key can decrypt. Now, how does this all relate to our ISA server? To understand that, you have to reverse the story. Instead of us being the client and accessing the web server, you're going to have the client out here on the internet. This is some mystery client that is accessing our internal web server over here. Web server. Now, this is going to be protected by none other than our red ISA server firewall. So here's the idea. We need to create a SSL bridging scenario where this client comes in securely using SSL, using HTTPS, but the ISA server terminates the encryption right there. The reason why we do that is so it can then look at what the client is trying to send the web server to make sure it's nothing malicious. If we just tunnel it right through, the ISA server has no idea what it's sending it, and that could be a malicious attack on the web server. Now, once we get over here to this side, we need to re-encrypt the data and send it to the web server. Also, vice versa, we need to make sure as the web server sends out, it decrypts right here, inspects, then sends the data back out to the client in an encrypted format. It's a tricky process, but all we need to do is we need to, I say all we need to do, but really it is kind of tricky. We need to make ISA server pretend to be this web server to the client. And when I say pretend to be, we have to do a really good job. Because remember, on this certificate, it tells who that web server is. So if ISA server is going to pretend to be the web server to that client and do just encryption and decryption right there, it has to use the same certificate as the web server. The way we do that, and it's different depending on IIS, Apache, there's all kind of web servers that we could do. IIS has the ability to export the certificate. You can go through an export wizard, and it will allow you to export the certificate to where you can then import it into the ISA server. Now, I don't have a web server with a valid certificate. That would take time and money to create one of those. So I'll just pretend that I have this certificate right there. You can export that from the web server, and the key is, the key, that's so funny, it's a pun. The key is that we have both the public key and the private key attached to the certificate. When you walk through the export wizard of IIS, to be specific, it will by default only export the certificate with the public key attached, because that private key should never be touched. I mean, the private is the decryption algorithm. If that got out, then this whole certificate is worthless because the decryption algorithm got out with it. So when we're exporting it from IIS, we have to make sure to select the option that we export the public and private key on the certificate and then import it to the ISA server over here. By doing that, the ISA server has the web server certificate, and it can pretend to be the web server when any client attaches to it, and that's just fine because it's using the web server certificate. Now this file, it actually is a file. It'll be whatever you decide to name it, .cert. And let me actually jump into the ISA server and walk you through what it would look like if we did import the certificate. Now, I may not have a secured web server with the certificate to show you the export process, but I can show you what it would look like on the ISA server if you were to do an import. And the export is pretty simple on IIS. You just right-click and export it. You just need to make sure to include the private key on that certificate. Apache, it's a lot more difficult if you're not familiar with Unix, but you can get the certificate out of there. Once you've got the certificate, you'll copy it to your web server, or not web server, ISA server, and open the Microsoft Management Console. This is the blank MMC. And I'm going to click on Add or Remove a Snap-in, click on Add, and choose Certificates. Click on Add. Now it's going to ask you, do you want to manage certificates for my user account, the service account, or the computer. I'll click on computer and choose the local computer, that's our ISO server, and hit finish. And that pretty much manages the certificate store for this computer. It stores those certificates on its local hard drive. So click on OK, and there's my certificates, and expand them out. And you have the trusted root CAs. And I mean, when you really get into the PKI, you really learn that there's a lot more than just one certificate out there. There's a lot of certificates. And I'm going to click on this personal folder. You can see there's no items there. And if I wanted to bring in a certificate from the web server, to let ISO server pretend it's the web server, you right click on personal, hit all tasks, and choose import. And from there it's just going to walk you through a wizard where you're going to browse and find the specific certificate that you've copied over. It will be a .cer if you export it from the ISO server, or actually it could be a .crt. It's one of those two. Either one shows up as an X509. And you'll browse and pretty much follow the step-by-step and import that into your ISO server. Once you do that, it will be made available for this process. And I'm going to walk you through this as if we had a certificate. You can see secure connection. I'm going to click on next. This is the same as it was for web publishing. Your internal server name or IP address, and we'll go ahead and just say 192.168.1.150. Choose to forward the original host header. Make all paths available on that web server. Next, it says accept requests for any domain name, or if you have a specific domain name that you want to accept it for. Again, exactly the same as web server publishing. Now it says, and this is the different part, what web listener do you want to use? And you can see, as of right now, HTTP web port is the only one that's there. I don't have any other ones. I need to add a listener to my toolbox for secure requests. I'll do SSL listener from EXT to internal. And I'll choose to listen on the external. Again, same thing as before. What address do you want to listen on? Next. But now, here's the difference. Uncheck that and check that. And now look at this. This is where, if we had that certificate, I would go in there and say, I want to select a certificate, and this is, I don't have anything in that personal store right here. If I did, that's where it would come up and say, okay, let me go ahead and grab that certificate. But I'm going to go ahead and click on next, and you can see it. This is the end of our story, ladies and gentlemen, because I have to have a certificate to pretend to be that web server if I'm going to use the SSL bridging, which is this one right here. If I were to go ahead and use SSL tunneling, then ISO server does not need a certificate. You can see the whole story changes. I just plug in the internal server address and configure what to listen for. And at that point, it will go ahead and automatically configure the SSL listening and everything like that, because tunneling is as simple as forwarding a port through. The ISO server stands back and lets that pass. Bridging is where you need that certificate to terminate that. Does that make sense? Do you see how that worked? That whole SSL bridging process. Again, all that we were missing is that certificate, which I would have to apply for from the public CA out on the internet, wait for a couple days, pay them some money, and get one. But that's the process of publishing a secure web server. Once you've seen the web server and secure web server publishing, it's all downhill from there. All that we have is the mail server and the new server publishing rule. Now, the only reason we have a separate one for the mail server is because it does allow you to pick specific protocols and use the same things a lot of times as our web server publishing did. For example, let's say I'm publishing Outlook Web Access, which is very popular to publish out. You can see that we have Web Client Access, OWA, Outlook Mobile Access, Exchange Server Active Sync, which is all done remotely. We have Client Access Protocols, POP3, IMAP, all those, or server-to-server communication, especially SMTP, which allows our email server to replicate to and from the outside web servers, or email servers. But for instance, Outlook Web Access, I'll choose, and you can see which ones do you want to do, how do you want to do this. You see how this is very similar, where you can go ahead and do SSL bridging to the email server to make sure no one is scandalously using Outlook Web Access to manipulate your internal email server. So again, this is very similar as it was before. We could also hop in, use POP protocols, choose what what protocols we want to do, what the internal server is, and it makes those available to the outsides. Essentially, this is just port forwarding made easy, with additional inspection added for a lot of times your email, Outlook web access. You have, for instance, SMTP that we're able to publish and make available to the outside world. And I mean, that's how easy it is to publish a email server. Finally, the server publishing rule, and you can see I'm flying through this because it's all stuff you've seen before. It's just in different order on the web pages and when we did the web and secure web. Let's say I want to make my Half-Life 2 server available to the public. 921.150. Next. Now we come into the protocol, and this is the protocols that we have added in our toolbox. We can always add a new protocol, and this walks us through the protocol definition where we can, and this goes back to our firewall where we define different protocols, what protocol they use, what direction, what port ranges it uses. So again, just making those commonly available servers, commonly used servers available to the outside networks. And configuring a listener on the correct interface is all that process goes through. So really, all of the concepts come in when you're publishing that web and secure web. The mail and other server publishing rules are a piece of cake once you understand the web and secure web. It's just choosing what protocols and what port numbers and what direction. So you can see that there really is a lot to server publishing, and much more obviously than I could have done in that single nugget. So just to hit the high points of what we talked about, we really focused in on the rest of configuring web publishing, as in tweaking it after we've created that initial rule to do the kind of application layer filtering that ISO server is designed for. We then got into securing publishing secure web servers, talked about the concepts behind using SSL bridging, SSL tunneling, making the secure websites available to the outside world in the best possible way. And then finally, forgive the flyby, but really as I was going through that wizard, I was saying this is nothing new. You've seen this before. This is just making other servers available through the protocol definitions that we've created back in those firewall nuggets, and then configuring the ISO server to listen for those ports on the external interface. I hope this has been informative for you, and I'd like to thank you for viewing.